Namaskar friends, welcome to session 5 of our course on manufacturing guidelines for product design. Just to have a quick review of what we have covered, we have tried to establish manufacturing guidelines or establish the basic fundamentals of manufacturing in context of the product design. So we have tried to address an important issue that when a product designer designs a product, he undergoes or he takes a step by step procedure or he conducts a step by step approach or procedure or a study to design a product, and towards the end of that product design procedure or product design cycle, two important points emerge, and those are the rapid prototyping and the manufacturing consideration. We have to see that how the prototype can be developed, and then further we have to see how the product will be manufactured. And when the manufacturing of the product has to be ascertained, a product designer must have some basic information related to the manufacturing processes. He may not be an expert of manufacturing, but he must have an basic idea of manufacturing, and that is the bridge or the gap that we want to address with this course. Many a times a product designer designs a very good product which is functionally excellent, is easy to operate, but difficult to manufacture. Now, why it is difficult to manufacture? Because the product designer has not considered the manufacturing guidelines or the manufacturing aspects during the product design process. And many a time these days a product design team is created in which there are experts from the manufacturing division also, but there can be exceptional circumstances where a student comes up with a product. He may be from civil engineering background. Now, civil engineering background student comes up with a novel idea of developing a product, for example for cleaning a water. Now, when the product has to be developed, he may not be knowing that how the product can be manufactured or what can be the intricacies during the manufacturing of this product, or he may have a problem in selecting a particular design because he doesn't know that whether this type of a design can be manufactured easily or not. So it is not required that he knows all the nitties and gritties of the manufacturing processes, but at least he can have a basic idea that yes, this type of a product can be developed using this process, or these are the manufacturing processes which can be used for converting my idea into a final tangible product. So with this basic consideration, we have attempted to develop this type of a course in which any product designer from any background can undergo the program or undergo this course or maybe learn this course and may become acquainted with the basics of the manufacturing processes and use this basic manufacturing guidelines during the product design process. And in that context, today our topic is process capabilities. We are just going to see the basics. Must I again address this point that there are hundreds of manufacturing processes and each process has got its own capability. So there can be different processes with the same name with little variation. For example, casting. In the last session we have seen we can do the casting by making a mold in the sand, or we can make a permanent mold of metal and then pour the molten metal into that permanent mold and get our final product. So the basic concept is casting, where a metal is melted and it is poured into the mold, but the molds are different. In one case it is a temporary mold that we make in sand, in the other side it is a permanent mold which is made in metal or which is made by metal. So the casting principle remains same, but the variation is in sand casting and the die casting, and both these processes which fall under the broader umbrella of casting have got their process limitations, their process capabilities, as well as the application areas also vary for these two processes. Within casting only we can have investment casting, we can have slush casting, we can have within die casting we can have hot chamber die casting, we can have cold chamber die casting. So we are not going to study the process details of these manufacturing processes, but we are going to study the capabilities of these processes. So the most commonly used among casting are the sand casting and the die casting processes. The other ones are also used, but are used for very specific type of applications. For example, centrifugal casting process can be used for making axisymmetric large size casting products. So we will see that what is the process. We are not going to go into the intricacies of the process, but what are the capacity of the process. Like for example, we have seen the criteria based on which we will select the process. If you refer back to our discussion in the second and the third session for this course, we have tried to identify a criteria. So what was that criteria? The criteria was that we will select a manufacturing process based on the raw material or the material which needs to be transformed or used as the raw material for converting into the final product. It can be wood, it can be a ceramic, it can be a metal, it can be an alloy, it can be a plastic. So you can have different types of materials which you will use as a raw material and then convert this raw material into the final product. So the process will depend upon the type of the material, the mechanical, physical, chemical properties of the material. Then it will depend upon the shape of the product that we want to produce. Accordingly, we will select the process. For example, if we have to do a large axisymmetric product, we may go for centrifugal casting process if it has to be made in metal. Similarly, the size of the product will also decide which manufacturing process we must choose. The quality that we are planning or which has been designed during the product design specifications, we have to select the process accordingly so that we are able to get the quality that has been designed by the designer during the process. Then there are other parameters, number of other parameters that will dictate our choice of the process that we will use for converting our idea into the final product. So process capability basically means there are two words here, a process and a capability. Like I as a person may have certain capability. I am recording a half an hour session, I may speak for 1 hour at a stretch, I may at a max speak 2 hours at a stretch, but I don't have a capability to speak for 24 hours continuously. I can speak, but the quality of speech will deteriorate. The you can say the pitch at which I am speaking may not be audible if I speak continuously for a long period of time. Similarly, each and every system, for example a battery we are using will have its own capability. If we are using a internal combustion engine, it will have its own capability to produce power. So depending upon the equipment, the process, the human being, there is a capability defined for each one of these examples. So here we are talking about process capability. So capability word I think I have tried to explain. Process means the manufacturing processes that we have discussed. We have seen sand casting, we have seen die casting, we have seen injection molding, we have seen compression molding. So different processes we have seen, and each of these processes have got certain capabilities. Now we will try to understand today what are the applications where sand casting can be used, because most of the time if we talk about a process and see the mechanism that how this process is done, we usually do not go to the application side. So basically in examination point of view also we try to prepare that how the process will look like, how to draw the diagram, what are the various elements of the gating system in, for example in sand casting process, but we usually do not focus on the application areas. So today we will try to see that what are the standard applications of the casting process, and we will try to see that what is the process capability. So the criteria I have already explained. Now what is the criteria? Criteria again I am listing out, I will not take examples now. The criteria can be the raw material that is used or the properties of the raw material, the shape of the product, the size of the product, the quality that we want to produce, and finally the number of products that have to be produced. If only 5 products have to be produced, we will definitely select a process which is suited for less or maybe a lower batch size, and if a large number of products have to be produced, we will select a process which is suited for a large batch size. So basically these are the 4 or 5 important criteria which will help us to decide that which process we must choose. And important point also is that we must know that which process is suited for which type of production or which type of manufacturing or which type of product, and that is what we will try to see. The only thing again I am emphasizing is that we will not be able to cover all the process capabilities of all the manufacturing processes, but our focus will be to align the thinking process of the learners that such type of information or this type of concrete very crystal clear information is available about the processes, and we must take advantage of this information while we are designing our products. So let us now quickly go through at least 3 or 4 processes today and see the application areas of these processes as well as what is the process capability of these processes. So let us quickly now go to the presentation and try to see the process capabilities of some of these processes. Now we can see what do we mean by process capability. So quickly I have already tried to explain, but let us now quickly try to formalize or maybe standardize the definition of process capability. So a great deal of general information is available on manufacturing processes in a wide range of textbooks and handbooks. So this general information is our target. We are not going to go into the specifics of any manufacturing process, so that is not our target. We want to have a general guidelines for each and every manufacturing process, whatever possible in our 20 hours of discussion. If you have gone through the syllabus that we are going to cover in these 20 hours, you will see that we have identified the most important processes which are used in industry, and we will try to establish the basic thumb rules or guidelines that must be kept in mind while we are designing a product. So a lot of information is available. So if we refer to the textbooks and handbooks, we can get lot of information related to the manufacturing processes. Each process can be analyzed to determine the range of capabilities. So this is what we will try to just highlight today with the help of certain examples in terms of attributes of the parts that can be produced. So this is very important. So parts that can be produced is related to our product design approach. So when we know that this particular part has to be produced, we will certainly have a design for that part, and that design we need to understand that how it can be produced in the most economical as well as in the most productive manner, and that is where the range of capabilities will come into picture. We must know that casting is capable of producing this type of a product, or machining is capable of producing such type of a surface finish, or forging is capable of giving me this much strength in my final product. So that capability we must be able to understand, we must be able to highlight, we must be able to keep in our mind while we are designing the product. So the capabilities can be expressed, already I have told, the capabilities can be expressed in terms of shape of the product, size of the product, natural tolerance ranges for the product, surface roughness, or we can say surface finish of the product, and so on. Maybe in the so on we can write the production volume. Maybe it can be 500 or it can be 50,000. So depending upon the production volume also we will decide that which process has to be used. Why? Because every process will have a capability. Some process may have a capability of producing only 500 parts in a day, whereas there can be another process which has a capability of producing 50,000 parts in a day and satisfying all other criteria. So if our production volume is large, we will certainly go for a process which can produce 50,000 parts in a day. So the production volume is also an important decision criteria when we have to select a process, and process we will select based on the process capability, that this process has got this list of capability, this process has got this is a list of capability, then we will match, or we will do the matchmaking. What are the requirements, what is the capability of the process, and then we will try to match the two, and then we will start our production process. These capabilities determine whether a process can be used to produce the corresponding part attributes. Now depending upon the part attributes will come from the product design, and this design can we manufacture or not, that will depend upon the capability of the process. So we have a product design with us. For example, this pen I am using, this design is ready. Now we have to see how many of such pens have to be produced, what is the shape intricacy of this pen, what is the material of which this pen is to be made of, what are the type of slots required. So we have the design ready with us. Now we have to see how this can be produced. Now how we have to find out answer? When we know there is a long list, or there is a plethora of, or there is a spectrum of processes available with us which can help us to produce this product, we have to choose the most economical, the most productive, the most efficient, the most effective, as well as the most important process from the quality point of view. Sometimes it may so happen that the process which is giving us the best maximum productivity or the maximum efficiency may not produce with the desired quality. So the quality is an important parameter which will also help us to decide the process. Many a times it has been seen that there are processes which will produce at a very fast rate but will produce many defective items also. So those type of processes, maybe if the production quantity is very large and we can afford some defective items, we will go certainly for those processes. But wherever we are very conscious about the quality of the product, we will discard these processes and will go for a process which may produce at a lesser rate, but the defective items are minimum, or maybe sometimes we talk about the zero defects also. So we don't want a defective item to be produced. So quality is important parameter, cost is important parameter, shape of the product, size of the product, tolerance range of the product. So there are different criteria which will help us. And another point is the process capability. The process capability we must know, then only we can select the process. If we know that, for example, the weight of the product, now we know the weight of the product is very small, so we cannot say that casting can be used for this particular application. So there will be a range in which sand casting is possible, or the range of the weight for which the sand casting is possible. Sometimes the weight may be so high we cannot use the die casting process there. So we must know that the die casting is suitable for a specific weight range. It is possible for a specific surface finish. Sometimes we may require a super finished surface, and in die casting that kind of surface finish may not be achievable. So how we can select die casting? We cannot select, but that decision will be better decision, it will be informed decision if we know that die casting has the capability to produce this much surface finish, or the surface finish in the range from this much micron to this much micron. So that is the importance of process capability. So once we know that this is a process capability for casting process, this is a process capability for forging process, this is a process capability for machining process, accordingly we can select our process. So let us take few examples. So capabilities of a range of manufacturing processes, quickly we will try to go. So this process already we have seen, casting. So casting is a manufacturing process in which a liquid material is usually poured into a mold. So the mold, as I have already told, One thing is the liquid material, which we can call as the raw material. So we have a raw material which is in the molten form, and the mold can be a sand mold or it can be a mold made in metal, especially in case of die casting process. So we have a molten metal, we have a mold. The mold is prepared as the exact replica of our final product, which contains a hollow cavity of the desired shape. So the mold is the exact replica, or it is a cavity of the desired shape of the product, and then the material that is poured into the mold is allowed to solidify. Two examples already given, sand casting and die casting, which I have already highlighted here. So this is the basics of the process. Now we want to make a decision. We must know what is the capability or the process capability of sand casting, and similarly for die casting. In terms of what? We want to see it in terms of the part size or the size of the product. We need to understand the capability in terms of the weight of the product which it can produce. We need to understand the surface finish which it can produce, and we need not memorize all this information. We can have standard textbooks, we can refer to those textbooks and see the capability, and that is important. We must know that this type of information is available and we can make use of this information. So now we can go for the capability and try to categorize or classify the sand casting and the die casting process in terms of part size, weight, surface finish, or sometimes it can be the number of products produced per hour, or sometimes it can be per day also, depending upon the size of the product. So these are the criteria or which will help us to make a tabular arrangement of the capability for sand casting as well as for die casting. So this is a basic sand casting process which we have already seen, and there are number of very good lectures available on sand casting process in MOOCs as well as the other courses of NPTEL. So we are not going to go into the details of casting process here. So this is an example of the sand casting process. We make a sand mold here, and this is our product, as I have already highlighted in one of the previous lectures also. This is the final product that will come out, and this is a core which is used for creating a hollow section in the casting. So the important point is we bring a molten metal and we pour it into the sprue. The metal moves through this gating system and enters the mold cavity, and after solidification we are able to produce our final product. So the sand casting, also known as a sand mold casting, is a metal casting process characterized by using sand as the mold material. So this is the sand, and we make a mold in the sand. So now this process has got certain capabilities. Now let us see what are the capabilities. This is a source for this information: Product Design for Manufacture and Assembly by Jeffrey Boothroyd, Dewhurst and Knight. So from this book this data is available. There can be additional data which is available. So we can see one of the criteria, that is part size. From part size point of view, the weight can be from 0.2 ounce to 450 tons, and minimum wall is 0.125 inch. So this is a minimum wall thickness which is possible using the sand casting process. Similarly, the surface finish can be the second criteria which will define sometimes the quality of the surface produced. So that is also in the range of 500 to 1000 micro inch. Then the shapes produced competitively, we can see here large parts which is giving the size of the product size which we can produce. So sand casting is capable of producing large parts with walls and internal passage of complex geometry. This is another from the complexity of the product point of view. So, fairly complex products can be produced requiring good vibration damping characteristics. This is from the application point of view. So, if we see now where to use sand casting process, so the weight is also specified. 450 ton is on the higher side, on the larger side. Large size castings can be produced. Minimum wall thickness is given, below that you cannot go, because during solidification there will be problems and there can be certain types of casting defects. But as a product designer, we can keep in mind that when we are designing a product which has to be made by sand casting process, we must not specify a wall thickness less than the specified value. Similarly, the surface finish also the values are given and the shapes produced are also given. So, this type of process capability tables are available and we must make use of these tables when we are designing our product. Now, let us see the applications for sand casting. We can see the engine manifold, you can see the complexity of the product here, and this can easily be made by sand casting. Engine blocks can also be made, machine bases can be made by casting. So, here if you look at these three things, all of them are large size and fairly complex geometries. So, we can say that casting, sand casting especially, has a capability to produce large shapes with fairly complex geometries. Now, the die casting, this diagram already we have seen, this is the final product that is going to be developed here. So, there are two die halves, one is moving and another one is stationary. Once they close, they create a cavity in between them, and once we pour the molten metal inside, it solidifies and takes the shape of the product. So, the molten metal is injected under high pressure into the permanent die set, usually made of steel. Material can be low melting point metals like aluminum. We have already seen this in one of the previous sessions. Now, let us see what is the die casting. Here we can see surface finish 32 to 85 micro inch. Maximum weight you can see 35 here and it is 20 for aluminum. So, the weight is not that large. So, weight is small only. Similarly, minimum wall thickness is also smaller as compared to the sand casting process. So, it is, we can say, smaller than the sand casting process, and this is the shapes produced competitively. This is similar to injection molding. So, whatever we can produce in the plastic using the injection molding process, similar type of shapes can be produced, or fairly complex shapes can be produced in case of the die casting process. So, we can see the surface finish range. So, we can get better surface finish in die casting process as compared to the sand casting. The range is mentioned here. Part size also, we can make smaller size parts with the die casting process with complex geometries. So, we can see that within casting also we have two different processes. Let us take some example. So, here we can see similar to injection molding, particularly suited where better mechanical properties are required. So, in die casting we will get better mechanical properties as compared to the sand casting process. So, what kind of products can be made? We can make consumer, commercial and industrial products like automobiles, toys, connecting or. So, automobile we can make different parts, different smaller parts or components which are used in the automobile industry. So, these are the aluminum parts made by die casting. You can see the size is not very large, small size parts are made by the die casting process. Principle remains same, the metal is melted and it is poured into the mold. In case of die casting, we inject it at pressure and it goes into the metallic die and the metal gets solidified there, but we are not able to make very large parts in die casting. Similarly, the connector housings are given here. These are the gears which can be made using the die casting process. So, we can very easily differentiate between the two now, where sand casting has to be used and where die casting has to be used. So, when we are designing a product, we must keep this process capability in mind, that where we are going to, if I am designing a product which is small in size, has to be produced in large quantities, we require very good surface finish, we must opt for a die casting process. Now similarly, injection molding process also we have seen in the previous slide. I will skip this and go to the injection molding, which is normally used for thermoplastics. We can see the wall thickness range here which is available, the surface finish is better, and shape complexity, small to medium size parts with intricate details and good surface finish. So good surface finish is from the quality of the product that we are producing, intricate details from the shape complexity point of view, and small to medium size is from the size point of view. So we can see that size is an important criteria, shape of the product is an important criteria, and the quality of the product that we are desired, or the quality of surface finish that we desire, is an important criteria. So we can see where injection molding can be used: small to medium size, complex parts where we require a very good surface finish. Surface finish range is also given, which can be easily attained using the injection molding process. Even when we are designing our part, the wall thickness also is, the range is specified, that it is, injection molding process has the capability to produce the wall thickness in this range. So the applications, the injection molding process can be used to manufacture thin walled, because the wall thickness is given, plastic housing products which require many ribs and bosses on their interior surfaces. So if there are ribs and bosses on the interior surfaces, injection molding is the process that has to be used. These housings are used in a variety of products including household appliances, electronics, power tools, and as automotive dashboards. And you can see a lot of range of parts which are made by the injection molding process. So thin walled products include different types of open containers such as buckets. It is also used to produce several daily use items such as toothbrushes or small plastic toys, many medical devices, toothbrushes, small plastic toys, medical devices using valves and syringes. So you can see injection molding is a very versatile process and can produce a wide variety of products which are small in size, which have very good surface finish, which are fairly intricate in shape, and when we have to produce in large quantity. So that this you can see is the capability of the injection molding process. Now similarly, let us finish our today's session with a very important process for plastics, that is the blow molding process. So blow molding is a manufacturing process that is used to produce hollow plastic parts by inflating a heated plastic until it conforms to the mold shape and forms the desired product. I think the definition slightly may not be very clear in the first reading, but let us try to understand it with the help of a diagram. In general, there are two main types of blow molding processes: extrusion blow molding and injection blow molding. And this is basically the diagram which will make it very clear. This is the raw plastic part, which is sometimes called as Parison also, P-A-R-S-I-O-N, Parison. And then this is the first stage. These are the two mold halves, they will close. Here the two mold halves have closed. This is the raw plastic part. Then we blow hot air inside, it inflates this plastic part and it adheres to the shape of the mold when we blow the air. Then the two mold halves will open and our product is ready. This is our product. Just a basic introduction of the blow molding process. Now what is the capability of blow molding? Let us see. This is another diagram of blow molding, which is a three-dimensional. This is the raw plastic part, this is the die half, this is the final product. So if the hot air is blown in from here, it inflates the raw plastic part and it takes the shape of the bottle. The source is also given. Number of good videos are also available on YouTube depicting the blow molding process. Now what is the process capability? Wall thickness size is specified, surface finish range is specified, 250 to 500 micro inch. Now what type of shapes can be produced? It can produce hollow, well rounded, thin walled parts with low degree of asymmetry. So we have to have a symmetric part or axisymmetric part only in case of blow molding. So it is advisable that we use this process for axisymmetric parts only. So hollow parts have to be made, well rounded thin walled parts can be made, and almost all plastic bottles are made using the blow molding process. Surface finish range is specified, wall thickness range is also specified. So we can see certain examples. So we can see a wide variety of plastic bottles are made by the blow molding process. So different types of plastic products can be manufactured by this process, such as bottles in different shapes and sizes, jars and containers, ducting, fluid oil tanks, mugs, toys. So large number of parts can be made using the blow molding. Most of the parts you will see are symmetric in nature. So with this we come to the end of today's session. The important thing that we have learned today is that each process has got certain capacity, some capability in terms of the surface finish it can produce, in terms of the parts it can produce, basically the geometry of the parts it can produce, the size of the parts it can produce, the tolerance range it can adhere to, the dimensional accuracy it can produce, and there is information available under wide variety of sources. Some of the information we have collected from one standard book on design for manufacturing and assembly, and we have tried to show that this information is available which a product designer can use during his or her design process and select the design ribs or bosses or wall thickness accordingly during the design process only, so that when the product is manufactured no problem is encountered from the manufacturing point of view. So with this we conclude our first week of discussion. Our focus primarily has been to introduce the basic concepts of manufacturing, the classification of manufacturing processes, then the process capability and applications of the most important manufacturing processes that are used for making different types of product. In our second week, our discussion will focus on the engineering materials and how they can be used for producing the parts, and as a product designer how we must use the information related to the engineering materials in our product design process. Thank you.